good time?
I think you could start off.
All right.
Go ahead.
Right on time. Hi, everybody. Thanks for being here. I'm Kevin Eisen. I'm a senior geological engineer from Barr Engineering. Been with Barr for about 25 years, practicing in the environmental assessment and remediation world. Barr, as a company, has been working on PFAS projects for over 20 years. I'm currently managing a handful of projects that are dealing with AFFF releases, drinking water impacts, biosolids, PFAS litigation, which I won't be talking about today. But what I'm going to be talking about is the dynamic landscape of PFAS regulation in the federal world, with a focus on the implications of PFAS as a hazardous substance. So first, Barr Engineering Company is an employee-owned firm. I'm seated in Minneapolis, but we have a wide presence as evidenced by 14 locations and nearly 1,000 employees. 50 years of client-focused problem solving. We're a company that focuses on natural resource development, management, restoration, and compliance. So, you know who I am, you know why we're here. Let's talk about that.
So when you say satellite,
Satellite office, it's probably a difference without much of a distinction. It's more internally focused. We've got all of our business units represented in other offices. Satellite offices tend to be more focused on projects or clients in those particular geographies. All right, I'm here today to talk about current actions, mostly federal, but I'll touch a little bit on state actions tangentially. I'm not judging or advocating the things that I'm presenting today, just going to share what they are and how they might affect you and your industries. I'm going to provide a high-level overview of the EPA's PFAS roadmap. I'll cover the March 2023 release of the proposed MCLs for 6 PFAS compounds. That's focused on drinking water. We're going to talk about air and the TRI, specifically the December 2022 de minimis exemption removal. I'll talk a little bit about effluent limit guidances. Oops. Just shrink my notes. We're going to talk about surface water, the ELGs, such as the January 2023 announcement that EPA is looking at PFAS in landfill leachate discharges to surface water bodies. And we'll talk broadly about the implications of the proposed listing of PFAS as a hazardous substance. I am saving time for questions, so please start thinking about what you'd like to ask me. So PFAS strategic roadmap. The federal regulations are dynamic, and they aren't as far along as a lot of the states. The states have developed their own regulations in a lot of different places. The previous presentation asked the question of what's the status of the states. That's probably 4 or 5 presentations in itself, because there are many states moving forward with their own regs in a variety of media. The federal roadmap looks at source reduction as their primary focus. So they're trying to reduce the upstream sources so they don't have to deal with it in the downstream. So some regulations being discussed today and being proposed as they relate to life cycle analysis and consideration of release accountability, historic and ongoing release tracking. They might not seem as applicable to your industries because you don't directly manufacture or apply them. The fire suppression systems come to mind when I think about the petroleum industry as something that everybody touches. So I think those things are going to have a longer term impact on your operations and permits as these regulations develop more. Build out of the regulatory framework, the roadmap focuses heavily on EPA's current mechanisms and their environmental authorities to address PFAS contamination. So RCLA, CERCLA, TSCA, and these permits. They're using the tools that they have to sort of increase their reporting and compliance through levers that they already have. It's a multimedia focus, so they're not just looking at drinking water, they're looking at surface water, groundwater, air, soil. Previous focuses have been more on water because it was a little bit easier to evaluate and it's a little bit easier to directly link to people consuming it. As this technology and the toxicity information grows, they're applying it to more and more media. EJ and ESG, I just want to note that the PFAS roadmap also talks about environmental justice and ESG goals as well. And I think that's important because what we're seeing in industry is not just regulatory driven, toxicity based driven change. We're seeing really the grassroots driving of regulations, sometimes through fear, sometimes through lack of information. I flew down yesterday. The movie on the plane was Dark Water, so I watched that. That was an interesting movie, not necessarily for its technical accuracy, but because of the messaging that it delivered. You can't trust industry and you can't trust government, so we need to take it upon ourselves. And that was really the message the movie gave. That movie's for industry. The movie's not very friendly to industry. So we're going to move on here. Recently, the MCLs were released just last month. So MCLs are proposed under the National Primary Drinking Water Regulation, which is under the Safe Drinking Water Act. It affects community supplies over 15,000 people. So again, this audience, you guys aren't municipal water suppliers, but drinking water standards often get applied to groundwater because we drink our groundwater in a lot of places across the United States. Surface water is also a source of water for a lot of places as well. So what we see through the National Primary Drinking Water Regulation is application of drinking water standards to groundwater standards. I also see this as something that's going to be implemented as part of NIPS permits. So as these new regulations get pushed further down the line and eventually become codified, we think we're going to see a lot more regulatory effect in different media as well. This proposed MCL includes MCLs and MCLGs, so non-enforceable maximum contaminant level goals, and the enforceable MCLs. Now, again, this is still proposal, so neither of these are enforceable at this point in time. The comment period is currently open for basically seven more weeks. At which point EPA will close the comment period, go into a darkened room, consider all the comments, respond to them, and make it rule. Just to reinforce the federal support of this, just yesterday, the Biden-Harris administration announced it was $6.5 billion of grants and loans to help municipal systems primarily to meet the PFAS treatment goals and requirements. All right, so what is the new MCL? The new MCL, G goal is 0. PFOA, PFOS. All right, quick show of hands. Everybody familiar with what big picture PFOA, PFOS is versus PFAS? Yes, I know all about it. Okay, not everybody does, so we're going to go into this just very briefly. PFOA, per or polyfluorinated alkyl substances. PFOA is an acid. PFOS is a sulfonate. O, back to our organic chemistry days, is an octa chain. So there's 8 carbons in a row. Carbon has 4 places where it can latch onto stuff. Okay. Polyfluorinated means all of those available places that aren't connecting to other carbons are attached to fluorines. The carbon-fluorine bond is the strongest bond in nature. I'm going to say that again. It's the strongest one in nature. And we've got a linear compound that's got fluorines all over it, except for the end. The end has a functional group to it, either an acid or a sulfonate. Why does that matter? Most of that compound is polar, and the head is nonpolar. I said that backwards. Most of that compound is nonpolar, and the head is polar. What that means is that the heads align with each other, and they form a film. That's why we have AFFF. It's an aqueous film-forming foam. So this chemistry is custom made to be sprayed to form a film, to remove the oxygen supply, and put out fires. There's lots of other applications as well. Talking about those today. But that's the big picture. PFAS is the family of compounds. There are many under that umbrella, and there's many distinctions among them. We have limited toxicity information about each of those individual compounds. You hear numbers between 5,000, 10,000 individual compounds in this family. Toxicity information is pretty well developed. PFOA and PFOS. Again, those are the 8 genes. Sometimes people call them C8. Okay. Gen X and PFNA, those were kind of replacement compounds. The earlier presenter talked about how there was a voluntary transition away from using PFOA and PFOS. There were other similar compounds still in this family that were being used, presumably because they wanted to have similar behavioral characteristics of those compounds, but also have lesser toxicity. So that was my understanding of the generation piece. Gen X, by the way, is the compound that the current EPA director, Michael Regan, so he was the former environmental head in North Carolina during the Cape Fear environmental issue, which was all about Gen X coming out, stacks, being transferred miles. We'll get to that stuff. Okay, what is the MCL? MCLG, maximum contaminant level for goal. They say it's 0 for these two. That's not uncommon. We do find that the goal, the aspirational goal for things that they say there's no safe level for is 0. So this isn't terribly unique, but it gives you a flavor of the toxicity information that EPA believes it has for those two compounds. So, okay, that's the goal, but what's the actual one that would be enforceable is the MCL, and that's at 4 parts per trillion, individually, PFOA and PFOS. Okay, 4 parts per trillion is about the limit of quantification at a commercial laboratory. You can get down to about half a part per trillion at your commercial labs, but we're talking about pretty low, and we're talking about clean media. So drinking water, brown water, we're not talking about sludges, we're not talking about wastewaters with a lot of other interferences that drive up those reporting limits. So the drinking water standard, which has a pretty good method, 537.1 EPA method, can reasonably analyze and detect down to 4 parts per trillion. Getting your facility results to 4 parts per trillion might be a different story, but we can measure it. We can get there. So these last 4 were a little bit of a surprise that they got added on. So this was just released in March of 2023 because these 4 weren't necessarily called out in the EPA roadmap. So when EPA dropped this bit of news, folks were a little surprised, but let's talk for a minute about what that hazard index means. These are pretty straightforward. 4 parts per trillion, this compound, you send it to a lab, you get your result. Hazard index is not the sum of concentrations. It's the sum of concentrations compared to individual guidance levels. So for example, your Gen X, take your site concentration, you divide it by 10 parts per trillion or 10 nanograms per liter. PFBS, divide by 2000. PFNA, divide by 10. PFHXS, which by the way is one of the most predominant compounds in AFFF. When we look at what fingerprint, if you will, or what are the characteristics of different compounds, those breakdowns can tell you some information about where that PFAS might have been coming from. But back to how this calculation works. So we're taking the sum of these ratios and obtaining a hazard index. EPA's used this before in Superfund cleanups. We look at a combination of different compounds. We look at the contributions to risk. They say, okay, you've got little bits of all of these cumulatively that represents a risk. And we're going to say if your hazard index is greater than 1, you have to do something. This is the first time that they've used a hazard index for MCLs. So it's kind of noteworthy. It's not all that different from other cumulative risk evaluations. Like you guys might be familiar with like benzoylpyrene equivalencies or TCDDs for dioxins. Those are a little different because those have like equivalency factors and then you sum those up and you're not comparing it to 1. Where here it's a pretty easy comparison. All right, so we were talking about drinking water. We're going to pivot now to surface water. So NIPD's permits are the vehicle in which we get regulated for surface water discharges. They use effluent limit guidance, ELGs. In January of this year, EPA announced its intention to revise the existing landfill source category ELGs to address PFAS from landfills. Okay, how many landfills discharge leachate to surface water bodies? Not very many. Oh, wait. So if it's operating, a lot of times they'll capture their leachate and spray it on top of the landfill, right? They'll just recirculate it so they're not generating waste. But once you close that cell, you can't reapply that leachate anymore. And sometimes you just don't have favorable conditions to allow that much moisture into your waste. You might want to keep your waste a little drier. So you send it off to the local POTW and you have them treat your PFAS because it's quite a bit more diluted. I'm sorry, you treat your leachate, not for PFAS, because it's much more diluted. You got, 100 million gallons a day coming, the leachate's only hundreds of gallons. So dilution was a solution previously for landfills, but EPA has changed that. They said landfills discharges to surface water are now going to be regulated for PFAS. There are also movements to protect specific surface water bodies in addition to this specific category. Barr 132 Appendix C talks about Great Lakes water quality and has special characteristics and considerations for PFAS in the Great Lakes watersheds. This is also important because I understand some states have the ability, like Texas, has the ability to take an MCL, once it's codified, use it as an effluent limit. Other states have rulemaking processes to go from a drinking water standard to an effluent limit, but some states don't. So back to drinking water standard, that's really a big deal because it has a lot of far-reaching effects on other regulations that might affect businesses. Big message, things are moving forward in surface water protection. NIPD's permitting is the vehicle in which it's happening. All right, let's go from surface water to air. So the previous administration codified the National Defense Authorization Act in a manner that allows facilities that report TRI to disregard certain minimal amounts of things, de minimis concentrations. That was codified in the NDAA because it is renewed annually. So it provided some flexibility to leave it out if political winds flowed one way or another. The proposed rule that came out in December of 2022 is to remove the de minimis exception. So 100 pounds a year. Geez, a concentration at parts per trillion seems like it'd be hard to get to 100 pounds a year of going out the stack. I mean, if you're not manufacturing it, right? But if you remove that de minimis exception, now you have to start looking a lot more closely at what might be going on your stacks. What are the materials that you're bringing into your facility and how might those be going into your processes? Are you doing any wet applications that you dry if you're a manufacturer? If you're a refiner, what are the list of chemicals that you bring into your facility? And have you been able to evaluate those to see whether or not they have PFAS in them? The SDSs aren't going to tell you. SDSs allow you to say 1% or less, or it's proprietary, sorry. I've done projects where folks are looking at what's in my facility. Let's do a mass balance. And it's like pushing rope trying to get the SDS folks to tell you what's in this product that my client is buying from you. So this is a chemical special concern, and for facilities that manufacture or use PFAS, they remove the de minimis. Again, the using of PFAS is where it's probably going to catch folks, or where the broader implications are going to be. I mentioned that I've helped some clients look at their current historical chemical footprints, and the SDSs aren't super helpful. Suppliers are not very helpful at telling you this. So the implications: you lose your 100-pound threshold. It expands your facility responsibility, pushes questions upstream. All right, PFAS as a hazardous substance. PFOS and PFOA are what I'm talking about. Those two 8-chain compounds. They were proposed. The comment period closed last November. So EPA is receiving, reviewing, and responding to comments in their pursuit of moving forward. February of 2023, so just 2 months ago, EPA submitted a final proposal to the White House Office of Management and Budget, indicating that it wishes to publish in the Federal Register a notice indicating that rulemaking is requested for public input on whether EPA should consider designating PFAS beyond just PFOA and PFOS as hazardous substances. So in November, they stopped receiving comments for the 2 compounds. And in February, they said, we'd like to start looking at other compounds as well to also be listed as a hazardous substance. Being listed as a hazardous substance in CERCLA has a lot of implications. You have joint and several liability. What that means is that if you own a facility and you use PFAS and there's a PFAS footprint there, you have full responsibility for that. You sell your facility and somebody else buys it and they don't have any all appropriate inquiry protection for you. They didn't go through the brownfields process. They didn't get a phase 1. They didn't do the phase 2 to look for PFAS. They own that property. They use PFAS. You both have full responsibility. It's joint and several. So CERCLA has broad, far-reaching implications for hazardous substances. By the way, that February 2023 request was approved on March 24th, so just a couple weeks ago. And the OMB cleared the proposal, signaling that the EPA can now open for comment the notion of potentially expanding the CERCLA PFAS scope. So more to come on that. August 2023 is the date when they're targeting for the final rule to be implemented. That's not far away. What would that mean? I think that has broad implications. It might be to other program listings, CASCA listing as hazardous substance under RECRA, getting into the cradle to grave sort of approach. That's a big deal. That's expensive. CASCA, that was a little bit earlier in the process. I think New Mexico had sent a letter to the EPA trying to get a RECRA listing for PFAS. But let's talk a little bit more about what the CERCLA listing means. All right. I show this image because just for context, all that Michael Regan was the EPA director or the North Carolina director. And his claim to fame was that aerial deposition at a facility flew to the soil, entered into the groundwater, entered into a surface water body. People drank groundwater, private wells. People got their water from Cape Fear. And those had Gen X, which was a special formulation by this one chemical plant. So it wasn't as though there was a broad mixture of things that couldn't be identified to a source. Hey, PFAS is everywhere. PFAS is everywhere, by the way. It is. But this one was pretty specific because they could peg this one compound and say, you guys were producing it, this is why it's out there. And they could use that science to say, these multimedia transport mechanisms are real. They're actually happening. It is going up the stack. It is traveling 6 miles away, 8 miles away. It is leaching into the groundwater. It's traveling in the groundwater. Why do I show you this? It's really important as this moves more forward towards being a hazardous substance to know your site. What are you bringing on your site? Are you helping out the local community by taking their biosolids so you can, fertilize your green space around your facilities? Maybe you're sending them a waste stream and they say, hey, we'd like to get you guys to take our biosolids because people don't want them anymore. Biosolids, project I'm working on, has a huge affinity to accept PFAS in it. PFAS, I'll back up for a second. PFAS does not absorb, when it's in groundwater, does not absorb onto soil particles very well. It doesn't get retarded in its groundwater migration. The lone exception to that is when we're talking about carbon-rich environments. That's topsoil, right? Or when we're talking about a wastewater treatment facility, there's a lot of organics there. And when PFAS is in there, it gets concentrated into those biosolids. And so we see biosolids with concentrations of hundreds of parts per billion of PFAS. Those get spread on fields. I'm working on a project now where PFAS laden biosolids were spread on fields as beneficial use, helping the agricultural community get nutrients for free, just for the price of shipping. They grow row crops on it, corn. They grow pigs. The pigs eat the corn. They need to water the pigs, so they pump the water out of the shallow groundwater and they give that water to the pigs. And the pigs drink the water, eat the corn. Well, the state regulator in this particular project said, we have some questions for you about this. Okay, in this particular operation, it was a CAFO, a concentrated animal feed operation. So this wasn't a situation where the pigs are, rooting around in the organic sort of mindset of like, one pig gets however much space. That's their deal. It's a CAFO. So their tagline was, the pigs never touch the ground. They're in a building their whole life. So we aren't going to worry about them rooting around in the soil that has these biosolids on it. Same state, different location, there was an organic cattle farmer. Got biosolids, had PFAS impacts. Cows are grazing, rooting in the soil, drinking the water that has PFAS impacts. Tested the cows. Cows came back lower than the FAA's, the Federal Ag Group has a special group that created a tissue number for consumption, for human consumption. It was below that. So the farmer thought, well, it's pretty good shape. But the state applied a health advisory to the cattle because they said, well, it's a small organic farm and you're concentrating who you sell to. So you're selling to the Eisen family and they're getting a quarter from you. Their risk is higher than our general risk profile. So we're just going to put a health advisory on. We're not shutting you down. That's exactly what they did. All right. So I just want to note that what's on your site is critically important. Right? Are you pumping water from a nearby surface water for a process? Are you pumping groundwater? Do you own landfills? Do you have partnerships with wastewater treatment plants? Do you receive anything from them or do you send it all to them? So knowing your site is pretty important. The other thing that's really important is knowing your neighbors. Right? You think about a standard phase 1 environmental site assessment. You're doing mergers and acquisitions. So, okay, we're going to do a phase 1 ESA. What does my site have for regulatory history? What are the regulatory history of the sites around us? What implications might those have? We might have an off-site source of contamination coming onto our property. Okay, that you get an exemption for under the all appropriate inquiry. So other things that may be affected as we go through this listing process. I think of M&As for this audience as a hugely important consideration. People buy and sell assets all the time, right? I've got this refinery, I got this segment of pipeline, I got, whatever asset class you're talking about. I would really just want to reinforce, it's important to understand your facility's risk profile. You do that by data collection, understanding what's being brought on your site and what's around you. Treatment. I'm going to touch on treatment briefly. How am I doing for time? 10 minutes. Great. All right. So I'm not going to spend a lot of time talking about treatment. Big picture PFAS treatment. This is a busy slide. It's meant to be busy because there's a lot of different things. For technologies. I like to think of the treatment of PFAS liquids, destructive technologies, absorptive technology, separation. I want to take it out of the water. How do I take it out of the water? You can filter it, nanofiltration or reverse osmosis. I want to take it out of the water by glomming it onto something else. Granular activated carbon. Remember, carbon was the one thing that it will absorb onto. People use GAC all the time to treat water for PFAS. Challenge is that lots of other things like to get absorbing GAC as well. Iron, manganese, naturally occurring things, other contaminants as well. So the trick with the absorption technologies for GAC anyway, like you have to pre-treat to remove everything else that would otherwise take up those spots so that you can be cost effective in the GAC treatment itself. Destructive technologies, incineration, cement kilns. Not that long ago, incineration was sort of the golden bullet. Hey, this is great. We're looking for these compounds. We send them through the incinerator. It gets up to 1,500, 2,000 degrees, and hey, it's gone on the tail end. It's not there anymore. That's great. Which compounds are we talking about? There's 5,000 of them. Are we talking about PFOA and PFOS? Are we talking about any of the telomeres? Are we talking about hexa? I mean, there are a long list of compounds that are present in these PFAS mixtures. And just as an example, DOD, who has the Department of Defense, who's been doing a lot of cleanups lately. They use AFFF at their facilities. They got an airfield. They need to test their firefighting equipment. You see a lot of AFFF releases at airports where they test their firefighting equipment. It is a really useful tool for putting out petroleum fires. That AFFF got into the ground, got into the groundwater, went off site, got into people's drinking water wells. DOD said, we need a better way to treat this. Let's do this incineration. Well, some studies came out and said it's not complete incineration. It's not complete destruction. So even though EPA says this is an okay technology, DOD said not for us. We're putting a pause on the incineration program for our wastes because we don't feel confident about it. So until EPA and DOD get their stuff sort of sorted out, I'd say that the incineration is a little bit of a risky proposition. Emerging alternate technologies, there's a ton of them. Let's save more time for discussion. I covered a lot of ground. Who's got questions? Do you want me in the picture for it?
No.
Yeah. About this tie just for today.
Yeah.
Say again? Oh, okay. Other, yeah, go ahead.
So if I get the petroleum oil to start to do that.
Yep.
So but starting to be advancements in two different sources.
Yeah, so the quick answer is no, these are persistent compounds. So they don't weather it very well. I mean, you know, there's a lot of sensationalism out there. These are forever chemicals. There's a reason they're called that. The carbon-fluorine bond is the most stable in nature. It doesn't break down very well. To your point though, can you distinguish between multiple sources? Yes, but not through age necessarily, through characteristics. You can look at relative ratios of what's the PFOS to the PFBS to the PFOA to the PFHXS. You know, and there's all sorts of pie charts that have different colorations based on the S or the A and, you know, the different compounds are. You can kind of, yeah, this one looks kind of like this one, and these compound characteristics are similar. So you can separate out distinct sources from one another. You know, your Scotch Guard barrel or your AFFF or fill in the blank. More like a forensic approach than a degradation. Somebody else had a question? Yeah, go ahead.
So I had a pipeline station.
Mhm.
We have these,
Yes.
so we're in the process of, we need to find a replacement just like everybody else.
Mhm.
But we have so much that's on our plate, so we're starting to dispose of it a little bit at a time. It's so expensive.
Mhm.
So you're a little hesitant on incineration, or you're not saying don't try and dispose of this, but I heard you say is that be cautious with incineration because.
Yeah, and the because is any analytical chemist will tell you what you find depends on what you're. If there are 5,000 compounds out there, and we know the toxicity really well of 2 of them now, we might know the toxicity of 10 of them 5 years from now, 50 of them, who knows what your time frame is, right? We know that incinerators transform PFAS. 10-2, the 8-2, those fluor telomeres transform. And you can, in other processes, do as well. Sometimes you'll have a concentration of PFAS coming into a process. And after that process, your PFAS concentration went up because other components in the PFAS soup transformed, lost their extra hydrogen or whatever other functional group was on there, and went to a C8 compound. So those transformations are the piece that give me pause. We can do stack testing. And we can look at very low concentrations. But I don't know that we have the analytical methodology to understand that broad family. Nor do we have the toxicity to really say, we're very comfortable with sending this compound at this concentration down the stack. These are just my opinions.
No, and loud clear, and just a brief follow-up,
Yep.
so our TSDF, or so they're going to be under further scrutiny, regulation. As a client, we should be that in mind.
Absolutely. Yeah, I mean, I think clients should be very mindful of where they send their wastes. Sending it to a landfill, is that licensed landfill with excellent liners, and that company has got a good operational history? Not dissimilar, but
Yeah, just looking at the version. Like a lot of any promising so far, how, how.
yeah,
Years, months.
well, I like to look at them as tools in the tool belt. So what do you got? You have a high concentration of PFAS in a low volume waste. Okay. This one, and this one might be good for you. So foam fractionation, it's a nice job. Foam fractionation, they bubble the liquid waste stream. Because PFAS loves those air-water interfaces, you bubble it, you collect the foam. Now you've got higher concentrations at a much lower volume. That could save you a lot of money. Oxidation is helpful in destroying things, but it takes a lot of energy. So you want to have a really low volume. So there's a bit of mixing and matching going on with different tools that you have, and it really is dependent on what the chemistry of your waste is. What are the competitions for some of the traditional technologies and some of the emerging technologies? And we'd love to help you. Go ahead.
Well, back to the parts per trillion.
Yes.
You were saying that they were migrating that to the difference per. Would that be the?
Right. So if the rule becomes codified, maybe in August, I'm sorry, got too many dates in my head. When the MCL goes from proposed to final, some states have mechanisms to apply drinking water criteria directly to surface water criteria. Not all states, but Texas, as I understand it, I'm not a PE in Texas. My marketing guy said, hey, I just heard yesterday. I'm sharing that. By the way, kudos to Nick Palitella for helping me put this together. Other questions?
So only if it is charging to the municipality, the concern PFAS monitoring.
No, I think going to groundwater, because people drink groundwater, going to surface water bodies, right? So the regulation driver right now is drinking water, but it will be brought into many different media as a result, sometimes very quickly, sometimes not so quickly. And part of the other part that I was talking about today is the other media are being developed in their own rights as well.
Okay, and so if she's sending a PFAS waste to be incinerated, which explained in your other slide,
Mhm.
Gets transferred in air. Then you're trying to manage cradle to grave and the destruction efficiency, or do you still own that air leaving that incinerator stack as it hits the land? And how would they be able to tell that was my PFAS and not his PFAS?
Jointed severally. I don't mean that facetiously. I mean, they're going to say, who all sent it to this incinerator? You all are going to help clean this up. So trusting.
That's the part that, the light bulb goes on, so I've already said, we need to talk about.
Yeah, I mean, these are, I say broad and far reaching, they are. It's a significant set of implications. And again, these are just two compounds at first, just two. But now they want to list other ones. We're close to out of time, but we haven't even really
Yeah, this is just the beginning.
touched on
Days.
two compounds versus a class of compounds without toxicity data. I mean, that's the Wild West. Good one.
Yeah, and well, also I think it's safe is I'm presenting that
Oh.
filling it for somebody.
I'm
Yeah,
sorry.
It's the exact same stuff.
Oh, okay.
And so I'm not a PFAS expert, but if you guys want to continue questions in the spirit of kind of what everyone's here, for this conference, by all means, if you're all right with it.
Sure,
To
thank you.
extend it, taking some of my time because it seems to be very similar to what I was going to talk about, nowhere near the level of detail, so.
Thank you.
Run out.
I just got,
Go ahead.
16, the other method's 537. It's very tough to relax. Area in non-drinking patrons. So now it's 1633, if you have 1633 compounds, you're going to require actual testing. That's going to be identified as source. In North Carolina, every single water monitoring. Proposed and are active.
Yeah, I mean, we're seeing it. So the approach that states like Michigan and Minnesota are taking, we want to look at the municipal wastewater treatment plant and see what they've got in their water. Because the traditional municipal wastewater treatment plant isn't treating for PFAS. So they can just look at that effluent and say, do you have it or not? Okay, but you do have it. Who's giving you your water? Let's start looking upstream. Let's look at that paper mill that's in your watershed sending you water. They're sending out 18 million gallons a day. What are those concentrations? But
Close that. It was a.
No, it was, it has been here the whole day.
Sorry?
It's been here the whole
it's
day.
going to be
Oh, there was one more regular.
I didn't do.
So
Somebody took it.
one of our clients is evaluating.
I'll put another one.
It's a product. There are trying to